Now, we have already seen about the conduction of heat, transmission of heat, three modes: conduction, radiation, convection. Now, we see the law of conduction of heat. Here, dq dq by dt. If this denotes heat, what is q? dq to q2 minus q1. Difference, so this is dq and dt is the time taken from q2 to q1. Therefore, this is the rate of flow of heat. The rate of flow of heat is directly proportional to the cross-section area of good conductor through which it is propagating. This is the cross-section area A. Therefore, dq is directly proportional to cross-section area. Next, temperature difference dt. Temperature difference is T2 minus T1. We can write T2 minus T1, but it is the dt is the short form of T2 minus T1. And suppose here temperature is T1, here temperature is T1, here temperature is T2. Here location from this point, here it is x1 and here it is x2. Then T2 minus T1, x2 minus x1. This is dt by dx. This is the temperature gradient. What is temperature gradient? Variation of temperature with respect to distance. When we heat an end of a rod, the heat comes from this end to the another end, transmitted from this end to the another end. In this way, at different place temperature is difference, and here place x1, x2, x3 and so on. So on different distances the temperature on the rod is different. The dt by dx is the dt by dx is the temperature gradient. Then it is found that the rate of change or the rate of flow of heat is directly proportional to the temperature gradient. Now, if we omit this is proportion. The proportion sign may be converted into equal signs and a constant. This may be replaced by these two. So here we at the place this we like this. On combining the two, it comes combining the two rules. Here we see one rule and here the another rule. This is one rule and this is another rule. On combining these two, we get dq by dt directly proportional to A and dt by dx, and after removing we shall get this dq is equal to ka dt by dx. Now here k depends upon the nature of the good conductor, so it is the nature of good conductor. Here it is known as coefficient of thermal conductivity or thermal coefficient of any body. Then how we can define the k? So for definition of k, we put in equation A equals 1 meter square, 1 meter square, and dt by dx equals 1 degree centigrade per meter. Then we shall get dq this will be 1, then dq equals k. Okay, so we put here all things 1, it becomes like this, dq is equal to k. Then how we can define in literature, it is mathematical definition कि k is nothing but dq by dt. I mean the rate of flow of heat. The in what condition the rate of flow of heat is called thermal conductivity? When we have the cross section area of the good conductor is 1 meter square and temperature gradient is 1 degree centigrade per meter. In this case, the amount of the rate of flow of heat will be thermal conductivity. अगर किन्हीं कोई इंग्लिश में नहीं समझ में आवे तो वो हमसे हिंदी में भी पूछ सकते हैं. धन्यवाद.